So let's start with our note paper here for today. So just so that we don't lose anything, we make sure to get this back. First and last and period number up top, please. Okay, we're going to title this paper Observations and we're going to do a little abbreviating. PERP for perpendicular, bisect, and then CONST for construction. So we're going to title this paper Observations from the Perpendicular Bisect Construction. And we're just putting this label on here so that we know that this paper goes with the other one that I gave you. These are your next two sets of notes in your Learning Targets 4 through 7 packet that you're going to be putting together. And this is a very important page that I'm going to be looking at to determine your grade on your use of appropriate tools strategically. So this particular construction is critical that you can not only do it, but identify the things that develop out of it. Okay? All right, so you have these two papers. Keep them both handy because we're going to be bouncing back between the two of those papers. All right, I'm going to start on the construction paper here. You can see that I put the perpendicular bisector as the title, and then I put plus its theorem and a bunch of other goodies because, like I said, there's a lot of things in this construction that tie together geometrically. Okay, so we have this line segment here in the middle of our paper. And the first thing we want to do is we want to name this line segment so that we can refer back to it. So we're just going to call this point over here on the left A and the point on the right B. Just take a step outside. Okay, get yourself together. When you're ready to be quiet, you can come back into class. If you can't, you can just hang outside. Okay, thank you. All right, so we're going to label this line segment AB. All right. I'm going to grab my tools here. I'm going to start with my compass tool. And I want to show you something with the compass tool. I don't want you to actually do this construction. I just want to show you something. So the other day, we were working on finding the midpoint of a line. So you're not actually drawing this, you're just watching it for a second. Okay? If I started with a small circle, like say this one right here, and I wanted to then draw a circle of equal size where point B was the center. And I came over here and I set my compass at point B and I drew this circle this way. You can see that these circles are too small to intersect. And so it makes it, it's kind of a useless activity in order to really try to find that midpoint. And so one of the things that we discovered the other day when we were looking for that midpoint was in order to make our circles overlap, we've actually got to have our compass setting open more than halfway. Now anywhere in this range out here is fine. If I do more than halfway with my circle settings and I get this larger circle here and then I go back and I make a circle of equal size from point A, you can see now my circles are going to overlap here, and that's going to allow me to find the midpoint of my line segment. So when you're creating these circles, you need to have your compass opening more than halfway. Now, some constructions will just say, for the sake of ease and, so that we don't have a whole bunch of variations in here, they'll just say, hey, you know what we want you to do? We want you to take your compass and we want you to set it to the whole size of the line segment. And that's what we're going to do today. So today what I want you to do is start by taking your compass and I want you to set it to the opening AB. So go ahead and set your compass to the opening AB. And then once you set your compass to the opening of AB, go ahead and lock that down. And again, you want to be as precise as you can with this particular activity. You're going to go ahead and draw a circle that intersects point B. That's a little wide. I'm going to come back just a little bit. So you want a circle that intersects point B with point A as its center, and then you also want a circle of equal size from point B. So we're going to be doing this construction that we used the other day to identify the midpoint of this line segment AB. And so we're going to do these two constructions here. So go ahead and get those two together. So you have these two circles. Now we know that where these circles intersect is where we're going to find the halfway point of that line. Whoops, you have a straight edge on your protractor. That's why I decided not to give you a ruler as well. You can use that straight edge. I'm going to use my ruler here. Your tool is actually going to serve two purposes for you today. So what I want you to do is I want you to take your ruler, and we want to line our ruler up here so that we can identify this line. And then I want you to draw the line that goes through the two intersection points, hits line segment AB, and extend it out past the two circles like that. So we've drawn this line now that is cut through line segment AB, and it connects the two intersection points of the circles. All right, we have some labeling to do here. So the first thing we're going to do is we're going to put a point right here at this center, and we're going to call that C. We're also going to put a point up here where the circles intersect at the top. We're going to call that, no, I'm sorry, not F. We don't want to call that F. We're going to call that D. So this will be point D. And then down here, this will be point E. So we have line segment AB. We've used our intersecting circles. We've found the midpoint C. Midpoint of line segment AB is midpoint C. We've also identified our circle intersections at D and E. Now, I'm going to introduce you to something today that's going to be a skill that I'm going to expect you to be able to do with progressing difficulty as we move throughout the course of this entire school year. Geometry is a lot like presenting a legal argument. And as we progress along through this, and actually we use the word proof to refer to these things, but it's essentially justifying your thinking, okay, in a logical order. You'll hear me use this analogy a lot. It's like making a case as a lawyer. Okay? If you were a lawyer and you were prosecuting someone for committing a crime, you would have to gather a bunch of evidence. You would take that evidence and you would lay it out before a judge in a specific order. You would say, well, because of this, I have these footprints and these fingerprints here, and because this camera showed at this time this person was here, and because we found this scene, this weapon at the crime scene, therefore all of this information comes together and we can say, so-and-so is guilty. You've gathered your evidence, you've presented it in a logical sequence, and you make a concluding statement. You're going to do a lot of that this year with geometry. So today I'm going to introduce you to the first time of kind of introducing this flow. And so, I want you to get the understanding that what we're doing here is we're presenting this logical case. And I'm going to start speaking a lot of math today. Okay? I'm going to speak a lot of geometry today. And so what I want to know from you is are you understanding? Are you understanding the words that I'm saying? And if you are able to connect the words that I'm saying to the pictures that we're drawing, then you're doing good. If what I end up saying today sounds a lot like German to you, then that means you need vocabulary work. And so I just want to lay that out there for you ahead of time to say, as I start talking math, you got to be able to do this. I'm going to expect you to be able to speak, read, and write geometry. Okay? That's what's going to get you the units and the credits in this class. So that's what you want to be able to do. That's what we're going to start writing out right now. So we've made this drawing up here. We have these intersecting circles. We know that this C is a midpoint. Now let's start kind of developing a legal case for some of this information. All right? So we're going to come back to our note paper here, and we're going to make observation number 1. And I want you to skip lines between your observation. And here's the first observation we're going to make, and we're going to write it in geometry language. So as I say it and I write it, hopefully it will make sense to you, okay? So line DE, so I use the proper notation for line DE, bisects segment AB. Line DE bisects segment AB. And so in the picture, what I'm talking about is I'm talking about the straight path that extends in both directions forever and ever through point D and E. That line cuts in half line segment AB, the straight path that starts at A and travels to B. Okay? Now, when we say bisect in geometry, it's a very specific word. Bi obviously means two. Sect is the same place where we get the word section, so we're cutting into two sections, but not any two sections. It's not like I'm taking a little bit off the front and leaving a bunch on the back, or a little bit off the back and leaving a bunch on the front. When we bisect something in geometry, we're cutting it into two equal parts. So the word bisect means that we're actually creating two congruent parts. Okay? Now, because line DE bisects segment AB, we can now make statement number 2. And so what I want you to do is I want you to draw an arrow from number 1 to number 2 so that you get this idea that the information is flowing from 1 to 2. Okay? It's this progressive presentation of information. Because line DE bisects segment AB, we can now say that point C is the midpoint, or the halfway point. It's the midpoint of segment AB. And because point C is the midpoint of segment AB, that allows us to make a third statement. So we want to connect 2 and 3. Again, the flow comes from 1 to 2 to 3. It's this progressive order of presentation of information. Because point C is the midpoint of segment AB, we can now say that segment AC is congruent to segment CB. Okay, here's the test if you can follow along. I'll give you a second to finish writing that down. Here's where you can check and see if you understand math language, if it's starting to make sense. Look at the picture and listen to what I say and see if you can follow along on the picture. Okay, we did 2 circles of equal size and we found they intersected at points D and points E. We connected a line through there, and so now line DE bisects segment AB. And it bisects it at point C. So point C is now the midpoint of segment AB. And because point C is the midpoint of segment AB, the line segment AC is congruent to the line segment CB, which means they have the same length. Did you follow? Okay. If you followed, then that means you're starting to speak the language, which is good. Okay. That's really encouraging. You should be very stoked if you understood what I just said. Because if you listened to what I just said, then you heard that it was a whole lot of math malarkey jargon going out my mouth, right? But if it made sense to you, then that's like the first time somebody starts speaking a foreign language and you understand it, okay? And there's going to be a lot more of that, and then I'm going to expect you to write it and read it and say it yourself, okay? So that's where we're headed. All right, now we gotta take this number 3 statement right here, and we got to mark that on our picture. So let's go back to the picture. Because if we're saying that line segment AC is congruent to line segment CB, then we want to put a congruency mark on AC and a congruency mark on CB. Phantom fan? Is that what's going on back there? Phantom fan?
Hey, Jesse.
All right, we need the fan going. That's good. Okay. Now,
Jesse.
I gave you a protractor. I'm going to get mine. Okay, let's refocus. I gave you a protractor. You should be pretty familiar with this tool. You're going to be using it quite a bit coming up real soon here. You're actually going to be using constructions to copy angles and then verify them at measurements. But let me just real briefly, for those of you who don't remember, if you haven't used this tool, I'll go over it real quickly. So this tool, the reason why it looks like half a circle is because this is the tool we use to measure the opening that exists between 2 rays that share a common endpoint, which we would also call an angle. Right? And so you can see the tick, 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 all the way across the half circle. Those are the little measurement marks along a circle that we say, how big is that opening where those 2 rays meet at that common endpoint. And so this tool is used for that. Now, I want you to notice something on the tool. You've got 2 sets of numbers, but those numbers always add up to 180 degrees. You got 160 and 20, you got 150 and 30, you got 140 and 40. And then the question becomes, as you're using the tool, which set of numbers do you use? Well, that has to do with whether you can identify an acute angle versus an obtuse angle. So when we get to measuring these things, if you're measuring an acute angle, you use the smallest set of numbers, less than 90. If you're measuring an obtuse angle, you're going to use the larger set of numbers, greater than 90. Okay? And so as we go along and we use this, you'll be able to do that. What I want you to do right now, though, is I want you to use this tool to measure angle ACD. Now, to do that, you've got a little hole at the bottom of yours. That's kind of like the crosshair where things go. You're going to set that hole right on the vertex of angle ACD. Now, again, if you're speaking my language, you should know what to do with that tool the minute I just said it. Set the hole at the vertex of angle ACD. So, of course, the vertex of angle ACD is point C, right? And so I'm going to take my protractor here. And what I want is I want this bottom line of my protractor to line up with my line segment AB there. And then I want my little crosshair to go right over C. And as I do that, I can see that as my line CD extends, we didn't put our arrows on line CD. We need to put our arrows on line CD, don't we? Let's do that real quick. We need an arrow down here. And we need an arrow up there. I'll do that in a second when I move my protractor. So this line DE so we can see that ray CD or ray CE both extend 90 degrees in measurement. So we want to mark that on our diagram with a square marking, a square angle marking. So we're going to go like this, put a square angle marking here. And then we need an arrow on this end here. Whoops, scrolling the wrong way. All right, there we go, that should be right. So now we've measured this, that angle ACD is in fact 90 degrees. We verified that with our protractor. Let's go make another observation on our notes. Now this observation is not connected to number 3. This is a separate observation. This is going to be number 4. I'm going to give you some new geometry notation language, so watch carefully. It's a lowercase m, and then the angle symbol, and then ACD. And then we'll do an equal sign this time, and we're going to say 90 degrees. I'm going to do a little arrow over here. This is red. The measure of angle ACD. That's how we would say that with the little lowercase m in front of it. It's red. The measure of angle ACD. And so now we're talking about measurements. We're going to use equality signs. And we're going to talk about numbers. So we've got this measure is equal to angle ACD is equal to 90 degrees. Okay? Now that's a separate notation for us. But we're now able to make a conclusion statement, which is statement 5. And statement 5 comes from 2 observations. It comes from number 3 and from number 4. So we want to draw 2 arrows, one from number 3 and one from number 4. Essentially what we're saying is we've got this piece of evidence right here that we proved up above. And we also have this piece of evidence that we proved with a tool. And because of this piece of evidence and this piece of evidence, we can now make this statement right here. And the statement is this. Line DE is the, and we're going to put this in quotes, perpendicular bisector of segment AB. So this would be an example of that legal presentation that I'm talking about. It's a progressive, ordered presentation of information that makes a case. If we wanted to make the case that line segment DE is this, what we call a perpendicular bisector of segment AB, we need to present this fact as we develop it up here. And then we have this observation that we made with our protractor, so now we can make this statement. Now let's be real clear about what we mean when we say this right here. So I want you to kind of underline perpendicular bisector here and swoop that down. And we're going to say this: perpendicular bisector cuts in 2 equal pieces at 90 degrees. It cuts in 2 equal pieces at 90 degrees. Now, it's important to make sure that we're clear about that because this is a special kind of bisector, all right? So let's say that this is my original line segment right here, right? I can cut this line segment in half with another line like this, right at 90 degrees, like we talked about, and this would be a perpendicular bisector. But that's not the only way I can cut that original line segment in half. I could cut it in half like this. Okay? That's still a bisector because these two lines intersect and they share one common point. So it still makes this first line segment cut into two equal pieces. But it's not a perpendicular bisector. This, when it comes to 90, is a perpendicular. And it's this special kind of bisector that ties a whole lot of geometry things together. Okay? So this is a very special relationship that exists, and as we go along here, you're going to see how many things are tied into this. And these are the things that I'll need you to be able to know, cite, and use in a legal defense of some particular case. Okay? All right, so with that being said, we have a little summary. So we're going to say this. Constructing a perpendicular bisector is the same process as constructing the midpoint You're real close. Understand? Jesse, it's time to go. So constructing a perpendicular bisector is the same process as constructing the midpoint. We're going to do a little side note here, a little in other words. Using overlapping congruent circles. So again, we're using these circles of same size that overlap. So it's that same process. All we have to do is just draw in the line. So constructing a perpendicular bisector is the same process of constructing the midpoint. In fact, as we just saw from our logical progression, the midpoint actually flows from the fact that we're building the perpendicular bisector. So we're using these overlapping circles. All we need to do is just draw in that line. Grab a paper right here underneath the sticks. Yes, that one. So constructing a perpendicular bisector is the same process as finding the midpoint. So now I can say to you, hey, construct the midpoint, construct the perpendicular bisector. Either way, it's the same idea. Using overlapping congruent circles, you find those intersection points, you draw that line through. Now you know that that line meets at a 90-degree angle and finds the midpoint. It serves two purposes in one for us. Okay. All right, so back to the construction paper. So here we are back at the construction paper. We now know that this angle ACD is a 90-degree angle. We know that line DE is this perpendicular bisector. We know that AC is congruent to CB. Now the question becomes, what about DC? What about line segment DC and line segment CE? Are those exactly the same? Look at line segment DC. Look at line segment CE. I mean, they kind of look the same, don't they? I mean, it sort of looks like point C is kind of in the middle of DE, doesn't it? But then the question would be, could we prove that geometrically using our tools? And we could, right? If we wanted to know, hey, is this point C the midpoint of DE? Then I guess all we'd really need to do is create some overlapping circles for DE. And if we had a line that cut right through here, that cut right through point C, then we would know that that's the midpoint. And so we're going to do that. So what I want you to do is I want you to take your compass, and I want you to set your compass to the opening of DE. So it's a larger opening. And so we're going to take our compass and we're going to set it to the opening of DE. So I'm going to put my compass point tip right here at D. And then I want to open my compass so that it goes all the way out and intersects with point E. Like this. So set your compass at DE. So these are going to be pretty big circles. In fact, I'm going to zoom out just a little bit here on my screen so that you can see a little bit better what I'm doing here. So I've got my compass set at the size of line segment DE, and I'm going to create these two overlapping circles that have a radius of DE. So starting with D at my center, I want to create a circle like this. So I got this big circle that has a radius of DE. And then I want to find its intersecting circle of equal size where my compass point is at point E. Okay, so I'm going to come down here to point E. And I want to make an intersecting circle that goes through point D like that. So I have these two large intersecting circles here. And you'll notice that actually our first circles also intersect with these larger circles as well. And so we want to label up some of this information. So now I'm going to go ahead and zoom my screen back into the middle. So you should have something that looks like this with these larger circles on it. My intersection points are off just a little bit over here, but we're going to call this one point F, and we're going to call this one we'll call the other one point G. So this other intersection point over here, we're going to call point G. And what we want to do is use our straight edge to draw a line through F and G. Yeah, and what we want to see is does that line that we're going to draw there, does that pass through our point C? And it looks like it does. So we have our line here, FG. Let's put some arrowheads on that. All right, so now we can see that actually by creating those intersecting circles here, not only okay, here we go. Here comes the test. See if you can follow what I say, because it's going to sound crazy. Okay. So not only did we find that line DE was the perpendicular bisector of segment AB, but at the same time, AB now became the perpendicular bisector, or FG became the perpendicular bisector of DE, and FG runs right through line segment AB. So point C is the midpoint on both line segment DE and line segment AB. So this one relationship exists between these two lines that we created here, okay? And this is where we begin to see all of this stuff starting to tie together, okay? All right, so we're going to get to the observations and writing this stuff down to, let's see, I see you guys tomorrow, 6, right? Yeah, I see you guys tomorrow. So we're going to finish this beginning tomorrow, and then we'll be launching into some practice on this as well, okay? So make sure you have this and your observation notes with you for tomorrow, because that's where we pick up, okay? All right, so let's start with a little review from where we left off yesterday. So we were building this particular construction, and I had mentioned to you that there's a lot of depth into this construction, and we're going to kind of start to scratch the surface of this today. But just by way of review, kind of what we started with. So we began initially with this line segment AB right here, and we wanted to try to find the midpoint of AB. So we drew these circles that had a radius of AB. So circle A here, that's the the blue circle on the left was the first one we drew, and then we flipped our compass around, we drew this one, and where those circles overlapped, we marked our end point. But then what we also did was we drew the line that connected through the two circle intersections. We labeled those D and E. And what we discovered in doing this was that DE cut AB in half at the midpoint, so that line had a relationship to that midpoint, and then that line also crossed AB at exactly 90 degrees, and we verified that with our protractor. So then we were starting to write some of this stuff down over here, and one of the things I mentioned to you was the importance of being able to make a logical flow of an argument, like a legal case, right? I've gathered this piece of evidence, and this piece of evidence, and this flows from here, and so therefore in the end I can make this concluding statement. So we talked about the fact that like here you can see that DE bisects AB. So because DE bisects AB, we can then make the statement that point C is the midpoint of AB. And since point C is the midpoint of AB, we can then make the statement that the segments from A to C and C to B are the same length. They're congruent, okay? And then here was where we verified the measure at 90 degrees. And then based on both this piece of information and this piece of information, we were able to make this last statement on number 5, that line DE is what we call the perpendicular bisector of segment AB. And this idea of a perpendicular bisector is going to become an important concept for you, being able to A, identify whether it is a perpendicular bisector, or B, define it via these constructions and these arguments, okay? And again, perpendicular bisector means that it cuts a line segment into two equal pieces, and it does it at 90 degrees. We talked about yesterday that you can cut something into two equal pieces, doesn't have to be at 90 degrees. All right, so that's where we left off yesterday. We want to summarize some of the things that we did because we continued along and we asked the question, hey, is the length from D to C here the same as the length from C to E here? And so then we constructed these larger purple circles. We made line FG. It went right through our original line segment, which made C the midpoint, not only of the original AB line segment, but it also made C the midpoint of line segment DE. So from D down to E, we knew that that was also a midpoint as well. So I'm going to go ahead and zoom this back in now a little bit, so that we have this a little closer to look at as we come back to working with it. And let's notate what we did this last part of our observation. So the next observation that we want to make is observation 6, which is that line FG, and we want to use our proper notation. Again, you're going to need to be able to read, write, and speak in geometry language. So line FG bisects segment DE. So line FG bisects segment DE. And I want you to notice something kind of interesting here. You know, when we were talking about DE earlier, look at point number 1. Look at observation number 1 on your paper. When we were talking about DE earlier, right, we called it line DE with the arrowheads on top, but now I'm calling it segment DE. Does that matter? Is it specific? You know, I mean, that becomes this, well, does it matter how I write it? Well, actually it does. I want you to think about something for a second. A line goes in both directions forever and ever, right? That means we can't say at this point right here is the middle. In order for us to actually have a middle, we've got to have a beginning and an end so that we can find the exact halfway point between the beginning and the end. And so it's important that when we reference this idea of bisection and midpoints that we're talking about of a line segment. We can't really say that we found the middle of a line where the line begins. We don't know where the line ends, but we do with a line segment. So it is important how we notate this, say it, and write it, okay? So it's important to say that line FG bisects segment DE in this case and not line DE. All right, now, based on that, because it bisects it, so observation 7 flows from observation 6, we can now say that point C is also the midpoint of segment DE. So point C was the midpoint of AB above, and now point C is the midpoint of DE. And again, I want to kind of emphasize this idea that if you're understanding what I'm saying, because I get it. If you don't speak geometry very well, like a lot of the things that I'm saying right now may not make sense to you. They may sound weird. So you can kind of gauge how you're doing in this class by how well you understand what I'm saying. When I'm up here and I'm going, yeah, line FG into the segment DH, and segment D is the midpoint and bisecting, and like if that all sounds foreign to you, then we have some vocabulary work that we need to do with you, okay? You got to build some of those language skills, okay? If you are understanding what I'm saying, that's good. That's a great sign, okay? Now, since we know that point C is also the midpoint of DE, then we can make this observation that flows from 7 to 8, and that is that the new line segment DC is congruent to the line segment CE. So DC is congruent to CE, which means they have the same distance. Their measurement is the same. They're the same length, okay? Now we want to be able to take this statement, DC is congruent to CE, and turn that into geometric markings on our picture, okay? So let's go back to our diagram that we're working with here. And let me grab a pen tool. All right, so what we're going to say here is we're saying that DC, this distance right here, is the same as the distance from CE, okay? But can I mark that with one congruency mark like I put here? Can I put like a 1 marker through here? No, because it's not. I can't do this, right? Because clearly AC is shorter than DC, right? So it's a different length, and so I'd need to use a different set of markings. So in this case, I've got to put 2 markings on here, okay? And so then that would allow me to come down here and put 2 markings down here. Now today you're going to be getting questions that have pictures associated with them, and you're going to have to be able to take the information that's drawn in the pictures and use that to help you solve problems. So for example, if you're given a picture and you have markings like this on the pictures, you need to know that those markings mean, you know, AC has the same length as CB, while DC has the same length as CE, but AC and DC are not the same, obviously from the markings and the size. Okay, so being able to read that off the pictures is really important. All right. Okay, I want you to take your protractor right now, and I want you to measure angle ECG on your paper, and I want you to mark it accordingly, like we did with angle ACD, I think we called it. So you're going to measure angle ECG right now, angle ECG. And I'm going to go get my protractor as well. So of course, ECG, angle ECG is this space in here. This is angle ECG in here. And so if we wanted to measure that, we would use our protractor. I would take my protractor and I want to line it up with this area over here so that my bottom of my protractor line lines up with my line DE, and then as I put this down here, you can see that angle ECG runs right through the 90 marking. I can make this a little bit bigger. So you can see it runs right through the 90 marking. That means that ECG is in fact a 90-degree angle. We verified that. Now we can mark it on our diagram by coming in and putting a square angle marker. That's all. That's right. So we can put a square angle marker there. Now, as we start to put more things on this picture, like for example, we've just established a certain particular kind of angle relationship that we're going to be talking about next week, and all of these things are going to show up on your next test. So a lot of stuff that we're going to learn for this next test is all going to be rooted right here in this one particular diagram that we are building with our construction tools. So it's important that you do understand all the components of this as we continue to move along with it, okay? All right, so let's notate what we just did there. We measured angle ECG, so we're going to come back to our notes paper, and we're going to say observation 9. This does not flow directly from 8. This is just an independent observation. And we're going to say that the measure of angle ECG was 90 degrees. We verified that. And so, again, just like we did above, because in this case of observation 8 and observation 9, we can now make statement 10. And so from 8 and from 9, 10 flows, which is that line FG is the perpendicular bisector of segment DE. So line FG is the perpendicular bisector of segment DE. All right, now look, if you look at observations 1, 2, 3, 4, and 5, and 6 through 10, you can see we've basically done the same thing, but we've established it with two different lines. So we established that line DE was the perpendicular bisector of our original line segment AB. And then by constructing a new set of circles, we established that line FG is the perpendicular bisector of segment DE. And hopefully you can find, as I say those out loud, hopefully you can find what I'm talking about in the picture. If you're able to anchor what I'm saying in the picture, then again, that understanding is starting to happen. You're starting to speak the language, which is good. That's what you want to be able to do. All right, now, you'll notice that in both of these summary statements, number 5 and number 10, we've made this whole point of identifying a perpendicular bisector, okay? And the question is why did we do that? What's the point of being able to say this line is a perpendicular bisector? Well, there's some really important things that tie together once we can determine that, all right? So let me give it to you in the legal analogy, all right? Certain guns make certain markings on shell casings, and so when the police go to a crime scene to try to collect evidence, you know, if they pick up a shell casing, they can match the markings on that shell casing to a very specific gun, and when those markings match up, they can say, hey, this gun was at this time and at this place, all right? And so that's how they link this stuff together. Same idea here. We've established a couple of things using this constructions. We say now, hey, look, we've got two perpendicular bisectors. What can we do with that? Now we can build on that idea, and so this leads us to what we call the perpendicular bisector theorem. All right, so this is what we need to flesh out right here. So we're going to go to the back side of your paper here, and we're going to flesh out this perpendicular bisector theorem. Perpendicular bisector theorem. So that last word is theorem, T-H-E-O-R-E-M, theorem. Let me give you a little briefer on that word. Circle that word and draw a little arrow up here. Okay, the word theorem essentially means this. Because of we can say this is what a theorem is. A theorem is a statement of fact that we can make based on some other things that we've established. Okay? So because of then we can say okay, whatever, you fill in the blank, all right? In this particular case, because of these intersecting circles and what we've established about these perpendicular bisectors, we can now say this, that if a point is on the perpendicular bisector of a segment, so if a point is on the perpendicular bisector of a segment, that point is equidistant from the end points of the segment. So because of what we established on the front of our paper, we can now say this, that if a point is on the perpendicular bisector of a segment, that point is going to be equidistant from the endpoints of the segment. And that sounds very mathy. I get it. So let's see if we can make some sense out of this. What exactly is this saying? Because it's this right here, it's this principle right here that ties together all kinds of geometric relationships. So this is a super, super duper important principle, okay? All right, so let's say, for example, we're going to try to make some sense out of this, all right? Now listen, this is right here is the crux of the lesson. This is what you need to walk away from with right here. You need to get this idea of what a perpendicular bisector does for us. If we can find one, it does stuff for us, all right? And this is what it does. Let's make observation 11, okay? This is pretty straightforward. Point A is on line FG. So we're going to connect this mathy kind of statement that was just made here, this perpendicular bisector theorem. We're going to try to connect it to the picture we just made. Okay? Point A is on line FG. Look at your picture. That's legit, right? If you look at your picture, point A is on line FG, right? That's pretty straightforward, right? And what do we know about FG? Well, we would say point A is on line FG, which is the perpendicular bisector of DE. So we established that in point 10 on the back side or on the front side of our paper. We established that line FG is the perpendicular bisector of DE. So if point A is on line FG and FG is a perpendicular bisector, then this comes into play right here. Okay, so if a point is on the perpendicular bisector, which point A is, then that point, which would be our point A, is equidistant from the endpoints of the line segment, the segment that's being cut by the perpendicular bisector. Okay, let's look at it on the picture. I'm going to come back over to the picture here. Here's what we're saying. Okay, any point along this line right here, please. Any point that sits along this line FG right here, because FG is a perpendicular bisector of DE, any point that sits on this line is going to be the exact same distance from D as it is from E, the two endpoints of the line segment. Let's check and see if that's the case. I want you to take your compass right now, and I want you to set your compass so that the opening measures the distance between point A and point D. So take your compass and set it so that it measures the distance from point A to point D. We're not going to draw anything right now. We're just going to use it like we were using it earlier in the year where we were measuring a distance, and then lock it down. Get that AD distance set on your compass like you see on the screen there. Lock it down. Okay? And then once you have that, what I want you to do is pick your compass up and then use your compass to measure the distance between A and E. And you'll find that, look at that. The distance between A and E is exactly the same as the distance between A and D. Now, why is that? Watch on the screen. You'll see why it is. Watch what I'm doing on the screen. I'm not actually drawing anything on the screen. I'm tracing something that was already there. What am I tracing? That was the first circle that we drew, wasn't it? The very first blue circle was the one that we drew. So what we drew that circle with was radius AB, right? But look where D is. It's on the same line, which means AD is really a radius of that first circle. So it would make sense that it's the same. And AE, for that matter, is also a radius of that first circle. So it would make sense that those points are equidistant to each other. Okay? So in that case, let's come back to our note paper here. Okay? We can make observation 12. Whoops. Which is that AD, line segment AD, is going to be congruent to line segment AE, and that flows right out of number 11. Because point A is on line FG, A's got to be the same distance from D as it is from E. Well, we need to get this included in our diagram. We need to get this on our picture. So we need some straight lines with some congruency markings that connect A to D and A to E. So I'm going to grab my ruler. You guys have your straight edge on your protractor that you can just use. And what I want you to do is I want you to connect a straight line from A to D and from A to E. All right, so we want a line connecting A and D. Went over a little bit. Let's try that again. We want a line connecting A and D, and then another line connecting, A and E, right? Because that's the other one that we were checking out. I'm going to be able to get that one so close. We'll try that. That'll work. All right, so then a line from A to E. Like that. All right, now the question becomes, how can we mark this with congruency markings? Could we put one line on there? No, because it's clearly bigger than AC, right? Could we put two? Are you sure? Well, how do we know if it's the same length as DC? We'll use our compass to measure it, right? Okay, so if our compass is already set, my compass is already set at AE, right? And AD. So if I just set my compass over here at point C, let me see how that compares to CE. Oh, look, it's clearly longer than CE, isn't it? So it's obviously longer than the one that's got two congruency marks, so what do we need to do? Yeah, we got to do three. Okay, so now we have three different measurements on here. So now we've got 1, 2, 3 like this, and 1, 2, 3 like this. Do you start to see any other shapes starting to develop out of this? No. There's some triangles in there now. We've got isosceles triangles in there. We've got right triangles in there now. All of a sudden, all of these relationships that we're going to start studying with triangles exist in here. And actually, there's all kinds of quadrilaterals in here as well. In fact, at the beginning of the school year, I told you that there was a reason why the interior angles of a quadrilateral, rectangles, squares, parallelograms, those types of shapes, why the interior angles add up to 360 degrees. And I said, circles of 360 degrees, that's got to be related. It's related by this drawing right here. This is the drawing that actually shows us that information. We're not there yet. We're going to get there. But there's a lot, and we're going to keep coming back to this particular diagram. And you'll see how these come together. Okay, so, but here's the thing. We did that with A, but does that work with every point? Well, let's check another one to make sure. So let's check and see if point F out here, right, is on line FG. So then if that's the case, and the perpendicular bisector theorem holds, then any point along this line should be the same distance to point D and E. Let's take and measure FD with our compass. So let's set our compass to measure FD. Because this one we did not draw a circle for, so let's set our compass to measure FD. And then lock that down. So this is my FD, and we're not going to draw anything with this, but again, you can see if I'm moving my compass, you can see we did not draw this circle. That circle is not there. We didn't draw that in, and I don't want to draw that in. I don't want to get this too confusing. But that's the measure FD. But watch what happens if I swing this around and I keep coming down here like this, even though I didn't draw that circle. When I get down to this point, boom, right there, it hits it. So both D and E would have been on a circle had I drawn it with that radius. So you can see that FD is the same distance as FE, and that's because of this perpendicular bisector theorem. It's because of these circles being held together at these 90-degree angles. All right, well, let's mark that one in as well. Let's write that over on our observation sheet here. So let's come over here and we can say, in addition to this, we can say that FD is congruent to FE. So line segment FD is congruent to line segment FE. That also comes from point 11, not from 12, but from point 11. So FD is congruent to FE. Let's draw those in. So we need some straight lines from FD to FE. Yeah, from F to D, and then from F to E. We come down here to FE. How does FD compare to the other line segments we have on here? Is it longer than AD?
Yes.
Okay, and AD was the longest one. It's clearly longer, huh? All right, so how are we going to mark that one then? What do you think? Yeah, let's put 4 on there. Yeah, that would make sense. Okay, so we have those markings on here now. All right. So here's the deal. Let me review this with you because it's super, super important that you catch this concept because this is the big point for today's lesson, okay? So let me review this with you so that you catch this, all right? Once we know that a line is a perpendicular bisector, like for example, line FG was the perpendicular bisector of the segment that started at D and went to E. Once we know that, then we know some information. Any point along this line is going to be the same distance from D as it is from E. Even if I picked one that wasn't part of our drawing that didn't have anything to do with these circles and intersections. Watch. I'm just going to pick a point out here, and let's call that point H. I don't know. I just picked some random spot on that line. But if I measure the distance between H and D with my compass, it's going to be exactly the same as the distance between H and E. No matter where you put a point on that line, it's always going to be the same distance from the endpoints because this line has bisected it at 90 degrees. Now, we can do the reverse of that. We can say, well, if some things are true, then we know that we have a perpendicular bisector.